This procedure is followed at Circuit Technology Center for BGA component assembly or rework. The procedure includes receiving, process development, BGA assembly and BGA rework process steps. The purpose is to ensure repeatable high-quality assembly and rework of BGA components and to assure conformity to the highest industry standards and specifications. The minimum skill level needed to complete this procedure reliably is advanced. The conformance level reached when this procedure is completed properly is high. See the web page for a list of the tools and materials required to complete this procedure. The procedure follows. A caution about operator safety. A thorough review of the equipment manual and comprehensive training are mandatory. Daily maintenance is essential. Consult the equipment manual for more information. A caution about component sensitivity. This method may subject the component to extreme temperatures. Evaluate the component's tolerance to heat prior to using this method. Plastic BGA components are especially sensitive to moisture absorption. Carefully evaluate pre-bake requirements. A caution about circuit board sensitivity. Circuit boards are made from a great variety of materials. When subjected to high temperatures, they are susceptible to the following types of damage. 1. Layer delamination. 2. Copper delamination, separation of pads, barrels of inner layers. 3. Burns and solder mask chipping. And 4. Warp. Each circuit board must be treated individually and scrutinized carefully for its reaction to heat. If a series of circuit boards are to be reworked, the first several should be handled with extreme care until a reliable procedure is established. Receiving and price quoting. Step 1. Upon receipt, the customer-supplied materials and products are logged into the Enterprise Resource Management System by the shipper and receiver. Customer-supplied materials and product counts are verified. Step 2. The project is reviewed by the appropriate sales application engineer to confirm the project requirements, determine the solder chemistry classification, and verify if a solder stencil is in stock or needs to be ordered. Repeat projects will have a previously created process sheet in the customer process specification database. A copy is be printed out and included with the job trailer. Step 3. New projects require a thermal profile for the circuit board. See the process step listed below and procedure 9.2.1. For profile development, we request a scrap circuit board assembly and extra components whenever possible. Step 4. Upon completion of the sales order, it is sent via email to the customer contact for confirmation of the process outlined and the charges listed. The schedule is confirmed and the customer products and materials are transferred to the BGA rework area. Project process development. Step 1. Prior to starting the project, the operator will review the following. A. Verify that circuit board and component part numbers and quantities match the traveler. B. Visually inspect the circuit boards for temperature-sensitive components or parts. Fiber optics, plastic connectors, batteries, etc. C. Ensure the BGA machine maintenance is current and the appropriate checks are done prior to operating the BGA machines. Step 2. All circuit boards are baked for a minimum of 12 hours at 125 degrees centigrade unless otherwise instructed by the customer. In addition, all BGA components that are received in unsealed packaging are baked per the moisture-sensitive device control procedure unless otherwise instructed by the customer. Step 3. Thermal profile development is required for all projects. If available, the operator will develop the thermal profile using a customer-supplied scrap assembly that is the same as the circuit boards to be processed. If the customer is unable to supply a scrap board, the thermal profile is developed during the initial removal process. In both cases, the operator will identify the following board conditions and start with the most logical machine setting. A. Solder chemistry, leaded or lead-free. B. Board thickness. C. Board and component density and layout. D. Component ball count and design. E. Underfill or conformal coating surrounding the site. The thermal profile is created by placing thermocouples at various locations to monitor and adjust the heating source time and temperature from the bottom side heat plate and the top side nozzle. Multiple machine cycles may be required to achieve the desired results. Upon completion, the profile is stored in the machine and saved in the customer process specification database for current and future applications. See Procedure 9.2.1 for more detailed information. Step 4. Additional notes are added to the customer process specification to identify special handling or other process steps that are needed in order to achieve an acceptable condition. These include adjacent components that need removal, specific masking or shielding requirements, and other conditions that may impact the process. BGA Rework Process. Step 1. Operators initially review the traveler and additional paperwork to ensure the instructions are clear and match the circuit boards to be processed. Any questions are directed to the sales application engineer or to the customer for clarification. Step 2. If circuit board disassembly is needed, all materials are labeled and noted on the traveler. Step 3. The operator will locate and load the removal profile specified on or with the traveler for the component removal. The removal process is visually monitored through a microscope. When the BGA component solder balls reach a molten state, the vacuum pickup of the component is initiated. Step 4. Site cleaning is done with a non-contact site cleaning tool or by using solder wick. If underfill or conformal coating is present at the site, additional steps are required to remove it. Typically heat, machining or chemical stripping of the site is needed. Refer to the sales application engineer, customer instruction or the product data sheet for the appropriate process. Step 5. No clean solder paste or flux is used for BGA assembly and rework unless otherwise instructed by the customer. Step 6. After the site cleaning process is complete, the circuit board is inspected to ensure the mask is undisturbed and the site is suitable for the installation process. If solder mask touch-up or other issues are identified, they are reviewed with the sales application engineer for direction. Step 7. Solder stencils are used to deposit the solder paste onto the site. Care is taken to ensure the paste is deposited evenly and completely. Step 8. The installation of the BGA component is completed following the programmed profile specified on or with the traveler. The installation process is visually monitored through a microscope, and when the BGA component solder balls and solder paste reach a molten state and ball collapse is confirmed, the placement process is complete. Note: high-temperature solder balls will not collapse and will rely on the paste wetting to the ball. Step 9. Upon completion of the placement process, the circuit board is visually inspected at the BGA placement site and all adjacent areas. Touch-up of the circuit board is completed if needed. Step 10. X-ray inspection is completed at the BGA placement site and adjacent areas. See Procedure 9.1.2 for additional information. Any potential workmanship or unacceptable conditions are reviewed with the sales application engineer for direction. Step 11. Reassembly of any removed components or hardware is performed. Step 12. Final inspection is completed by QC inspection.